Okay, so let's just go through very quickly. The topic on heat. Okay, can you see my screen? Can see, yeah? Okay. So let's watch the video first.
Heat transfers through our environment all of the time. I'm sure you've noticed that walking on a beach in summer feels hot, diving into the pool feels cold, and eating an ice cream cone on a hot summer's day goes from cold to cool to warm to melted all over your hand at a rapid rate. Heat transfer happens to us all the time, every day. It always moves from hot objects to colder ones and is impacted by some materials more than others. In this lesson, you'll explore 3 ways heat transfers in our environment: conduction, convection, and radiation. Conduction is the transfer of heat between substances directly contacting each other. The better the conductor, the more rapidly heat will transfer. Good conductors include copper, silver, iron, and steel. Poor conductors include wood, styrofoam, paper, and air. It's why we don't recommend picking up a handful of change that's been sitting in the sun unless you want to burn your hands. But you're okay to pick up that pile of wooden nickels sitting next to it. Moving on to convection. This is the up and down movement of gases and liquids caused by heat transfer. As a gas or a liquid is heated, it warms, expands, and rises because it's less dense. When the gas or liquid cools, it becomes denser and falls. Warming and rising and cooling and falling creates a convection current. This is the primary way heat moves through gases and liquids. Some examples include the warmer water on a pool's surface, floating in a hot air balloon, and that cool evening breeze blowing through the lower floors of your house or apartment. Finally, let's talk about radiation. This is defined as electromagnetic waves traveling through space. When electromagnetic waves come in contact with an object, the waves transfer the heat to that object. It's heat traveling in the form of visible and non-visible light. Some examples of radiation include feeling warm while standing next to a campfire, reheating that slice of pizza in your microwave, and turning on a light so you can find your phone. Conduction, convection, and radiation are 3 critical ways heat moves through our lives. They're the heat transfer principles we experience every day. Knowing how heat transfers makes it easier to find efficient ways to warm and cool our houses, keep people safe from overheating, and create new and innovative technologies to improve our lives. This completes this lesson on heat transfer, conduction, radiation, convection.
Okay, so very quickly, just the main points. So when we talk about heat, you need to understand what is expansion, what's contraction. If they ask you to define, you have to write this down. And then in our daily life, examples are extremely important. Okay, and a lot of times you are asked to actually explain what is happening. When you are given certain examples and then they ask you, all right, how does expansion and contraction, all right, give us problems in our daily life, you can actually state, okay, like bridges, if there are no expansion gaps, what will happen? You will see, okay, the bridges, right, certain parts will actually bulge out this way. Why? Because under the hot sun, all matter will expand. Okay, so also list down examples if they were to ask you, state how expansion and contraction in our daily life has been actually taken note of and actions are being taken to actually prevent problems in life. So these are also the examples you put down. How do you measure temperature? You use thermometer. Okay, the one that we use in the lab is always in degrees Celsius. However, SI unit for temperature is Kelvin. You need to know this. Capital K. Even if you, let's say, accidentally write a small k, they will mark you wrong. Right? Okay, so before I forget, now if you are asked to write down unit for temperature in terms of degree Celsius, if you write down degree Celsius, they mark you wrong. You need to write down very carefully. It's a very small degree, right? And then the Celsius is in capital. They are very particular. If you are going to write down degree Celsius this way, also mark you wrong. Okay, this is what I know how Cambridge actually mark exam papers. Units important. Kelvin is like this. Okay, like I told you, right? It's in capital K. So if you're talking about 250 Kelvin, it has to be a capital K. If you write down 250 this way, mark you wrong as well. They are very strict. Okay. Next. Bimetallic strip. Common question they ask as well. So you need to explain how it works. Have you all tried answering questions like this? Okay, you need to really explain how this thing works. What's the science concept behind it? Okay, so bimetallic strip, is made out of two different metal strips. All right. So you can actually make your own, at home. Okay, you can Google and find out, Haresh, you can do it on your own. So when heated or cooled down, this flat strip bends because one metal expands or contracts more than the other. Okay, so because of this fact, okay, they are actually used in bimetallic thermometers and thermostats. So they help to control temperature. Okay, let's say when it's too hot, then it will bend such that there's contact, electric current flows, aircon can work, cool air comes out to cool the room. But if it's too cold, what will happen? Okay, it will bend another direction, so there's no more contact, cut the electricity supply, and then the cold air doesn't flow out. Yeah, so that's how aircon works also. Okay, so I know you have gone through this. Just take a look at this interesting video.
This is a demonstration of thermal expansion. What I have here is a bimetallic strip with one type of metal on one side. It looks to be brass or bronze, and another type of metal on the other side. These two pieces of metal are adhered to each other. And when you heat this strip, these kinds of strips are used for switches, thermostats, this sort of thing. When you heat the strip, given the fact that the two metals will have different thermal expansion coefficients, one will expand more than the other, and it will curve, the strip will curve. So I'm heating on both sides to convince you that I'm not cheating by just heating one side and having it expand. So that is a bimetallic strip.
Okay, have you all tried this before in a science lab? Never. Okay. All right. And in the past, during my time, many years ago, we tried that. Okay, but then I think nowadays they try to reduce the chances of you having to heat metals, okay, because accidents can happen easily if you're not careful. Okay, so the three ways heat are being transferred. Firstly, conduction. So take note, conduction is the transfer of heat, okay, through a material, all right, without the obvious movement of the medium itself. Okay, so the medium, you don't see anything moving, right? So for example, okay, we can talk about metals. Metals are very good conductors. So heat are actually moving within that material. Okay, now uses for conduction, example, bottom of an iron. Do you iron your own clothes? So if you do, you understand how heat is actually conducted from the iron to your shirt or to your pants, etc. Okay, now oven gloves also. Okay, oven gloves, why are we applying in this manner? Oven gloves actually contain the trapped air. We know that air is actually a very poor conductor, so that will prevent heat from being conducted to our hand. Okay, so you don't burn yourself. Right, these are just very brief summary notes. So lastly, okay, sorry, next one is convection. Okay, so how do you actually talk about this? Okay, it's actually transfer of heat from one place to another by the movement of the medium itself. For example, liquid, for example, gas. You remember all these examples that probably were shared with you. Okay, so when the particles are moving, okay, you actually see certain movement. Okay, especially the one where you involve the ink in the water. Aircon as well, in the aircon room, how does the whole room get cooled down? Okay, because cold air actually sinks and then hot air rises. All right.
All right, so here we have a way to demonstrate convection, which you normally wouldn't be able to see. But in this case, we have this container, which is half filled with cool water. It would be wonderful if it was ice cold. That might even work better. But this represents part of the atmosphere or the air. And then we're going to put 3 drops of food coloring, one in the middle, which will be red, because that's going to represent warm air, which we'll show you in a minute. And then we're going to put 2 sections of blue food coloring on either side, and that will represent cool air. When we move the hot water underneath the red food coloring, that will represent the uneven heating of the Earth's surface. And we will see what happens here as we add some hot water. And I will zoom in here. So again, the hot water represents the uneven heating of the Earth's surface, which should create some extra warmth in our atmosphere there. And we're going to watch this red food coloring closely. If all goes well, it should start to rise. And there we see, if you look at the bottom of the food coloring, we can see the food coloring start to rise, which means our water is warm enough. And so that's creating an area of low pressure as the hot air rises. And as it rises, we can already see that the blue food coloring, which represents the cold air, is moving in to replace the warm air that is rising. So it's moving into that area of low pressure. And that is a good representation of convection, which creates air movement or wind. All right, so here we have a way.
Okay, can you see how the current is actually moving? So right in the center, they actually put the cup of hot water, right? So the hot vapor from the water warms up that area. Okay, so you see that the red color ink rises. As the water there that is being warmed rises, cool water will come in from the side to take its place. That's how you see the current. Okay, and that's how water gets heated also. All right, now the next example to show you about the convection current. Okay, this one is something that I like. All right, not sure whether you have done this before or watched this. Okay, but you could have seen the example inside your book.
This is a demonstration of convection in gases. What I'm going to do is I'm going to light a little candle like this. Okay, not only is it romantic, but it will also heat up the air just above it. Air, which is heated, will often rise. Okay, so what I'm going to do is I'm going to use one of these smoke matches here to produce a bit of smoke. And we're going to see how it ends up moving. Whoop, there we go. Okay, if I put it above here, the smoke seems to want to go up. If I put it above here, there's a lot of smoke getting drawn down. You see that? Yeah? You see it's going round inside this chamber and out the other side. Have you got any suggestions?